We're going to talk about linear functions. A relation between two sets is a collection of ordered pairs containing one object from each set. If an object X is from the first set and an object Y is from the second set, then the objects are said to be related if the ordered pair XY is in the relation. A linear relation is a relation whose ordered pairs form a straight line. You have experience with linear relations in grade 9. A linear function is a linear relation that passes the vertical line test. The most common ways to represent a linear function is either through a graph or an equation. So we are going to talk right now about a linear function. There's two ways to do it. One is through an equation. One of them is through a graph. Through an equation, the degree of the equation is 1. So suppose that we have y is equal to x plus 2. The highest exponent for either variable is 1. If this is true, this will form a linear relation. The second way is by a graph. How can you recognize a linear function? Well, the function is a straight line, and the straight line passes the vertical line test. So if you have a straight line, it is a linear function. Let's take a look at what word is in linear. Straight line. Let's look at example number 1. Graph each equation using a table of values. Which equations represent linear functions? So my table of values, this might take a little bit of work. I'm going to create a t-chart for x, y. People often get stuck here and they say, I don't know what x values to choose. Well, with linear relations, it doesn't matter. So generally, I go the x values that are easiest to calculate, and I also choose x values that are a little bit far apart. I'm going to choose x is equal to 0 and x is equal to 3. If you want, you can also calculate 6. Why 6? Why not? If I could ask you a question, how many points do you need to graph a line? The answer is 2. So anyway, I'm just going to get started here, where x is 0, y is going to be 2. And on a separate piece of paper, y is equal to negative 3, x is 0 plus 2. Y would be equal to 2 when x is equal to 0. There we have it. And I'm going to make the same argument for more of these points. I just realized to the left, there's actually a table of values started for me. When x is equal to 1, what is my y value? Y value is going to be negative 1. So when x is 1, my y value is negative 1. Now here, when x is 2, my y value is going to be y is equal to negative 3 times 2 plus 2. Y negative 3 times 2 is negative 6 plus 2. And what I get is negative 4. Now I can continue on like this, but I'm just going to fill in the table. Now, I actually don't know specifically maybe what I'm doing, but I just plugged it in. Now remember, you could recognize a linear function from a table of values. That is, if we increase by the same amount, by a constant amount in the x, and here we're going to increase by y, or 1, the y value also changes by the constant amount. And here the y value changes by -3 each time. All right, I'll graph this. And my first point that I can graph is -2, 8. So that's my first point. My second point is -1, 5. So I go -1, 5 is somewhere right there. My next point is going to be 0, 2. 0, 2, right there. My next point is going to be 1, -1. 2, -4. 3, -7. Now, the hard thing for me, not for you, you hopefully have access to a ruler in front of me. I don't. So what we notice is that it should follow an exact straight line. There is example number 1.